Today looking at some quadratics, thinking about a lot of different things with quadratics, looking at all these characteristics. And so let's see what we can figure out here. So first of all, we have a quadratic that's already been graphed for us. Made a t-chart here, graphed these points so that we can see what's going on with it. And notice here, very important is our vertex that I have right there in the center of my table. And so here's the quadratic we're looking at, y equals 2x squared plus 8x plus 6. So we're just going to go through some things. I'll try to explain as we go. So first of all, our leading coefficient. The leading coefficient is 2. The leading coefficient of our polynomial here is 2. That is our a value. And, well, is this going to open up or down? It's going to open up. We know because our a value, our leading coefficient, was positive, it opens up, and we can see that is what happened on our graph. The y-intercept, we can see right there our y-intercept is 6. We could write that as the 0.06. And we know the y-intercept is always going to be the c value, that constant term of our quadratic expression. The domain here, the domain is going to be all real numbers, because we can plug in any value for x we want to. It is moving to the left, it's moving to the right, it's covering all these x values on our x-axis. So the domain's all real numbers. The range, we're talking about y values. The lowest y value is right here at -2, and then it can be anything above that. Y is all values greater than or equal to -2. The axis of symmetry. A lot of people understand what we're talking about with axis of symmetry, but they still give the wrong answer. We know the axis of symmetry is talking about this vertical line right here going through the vertex, and we can see, yes, it would be symmetric. We could fold it over this line, but a lot of people want to give the answer. They see that value right there is -2, and they want their answer to be -2. That's not the axis of symmetry. The axis of symmetry is the vertical line going through this point right here. And a vertical line is always going to be x equals whatever the x value is. So in this case, it is x equals -2. That shows that we know how to state the equation of the axis of symmetry. So it's x equals -2. The vertex, we already decided the vertex was that point -2, -2. Is it a minimum or a maximum? It's certainly down here at the bottom of our parabola. It is a minimum. How many zeros? Well, we can see there are 2 real zeros here. One there, one there. There are 2 real zeros. What are they? They are the points -3, 0 and -1, 0. Interval of increasing and decreasing. Well, when we talk about these, you don't really have to do one first and then the other. I would always start to look from the left and move to the right. I would read the graph from the left to the right. Starting over here at the left. Over here at the left, this is -infinity for our x values. Over here at -infinity, as I'm moving in this direction, what is happening? The graph, the parabola is decreasing. As I'm starting over here and I'm moving to the right, I am decreasing until I get to the x value right here in our axis of symmetry of -2. It decreases. All of this is decreasing as I move from the left to the right, as I move from -infinity to -2. So I would do the interval of decreasing first. It decreases from -infinity to -2. That is the x values in which it is going down. So as long as x is between -infinity and -2, it is decreasing. And then right here at -2, it begins increasing again as I continue onward to positive infinity. It increases again from -2 to positive infinity. It increases. And I'm not going to say equals, because right here at the vertex, it is not increasing or decreasing. So we do not say equals there. We also can never equal infinity. So we're not saying it equals that. When x is greater than a -2, but less than that infinity, that is when it is increasing as I move to the right. Finally, in behavior. As x goes to positive infinity, as our x values move over here to positive infinity, that is x going to the right. What is the right side of our graph doing? Our y values, f of x, are going up. F of x is also going to a positive infinity over here. This one says as x goes to negative infinity, as our x values move to the left to negative infinity, f of x, y values are also pointing up. So as x goes to the left, we're saying it points up. That is what the statement says. This statement says as we went to the right, it points up. So both the left and the right sides point up. Vertex form. Here's vertex form for a quadratic. We want to put this quadratic in vertex form. We do have a formal process for this. We could complete the square, but we also could just understand vertex form. We know it's going to be f of x equals. We know it's going to be the same a value, which is 2, outside of my set of parentheses squared. It's always going to be x minus h. H and k, that is the vertex. So it's always going to be x minus the x coordinate of the vertex. So I have x minus a -2. On the outside, I'm adding the y coordinate. So I'm adding a -2 on the outside. If I clean this up just a little bit, I have f of x equals 2, outside of x plus 2 squared minus 2. It always appears as the a value is exactly the same as it looks in our original standard form. It's always going to be x in the opposite sign of the x coordinate of the vertex. The opposite sign of -2 is a +2, and then the same sign of the y coordinate on the outside.